Good morning, everyone. And a traditional hope you see me, hope you hear me, as is the nature of the events that we are carrying out now. I want to welcome you all to this EHPA Energy Transition Series webinar, this time on high-rise buildings. Firstly, I hope you and those around you are well in difficult times. And again, we very much appreciate your presence here, as well as your active participation in the chat. My name is Stefanica, and I am the project manager for the projects team of EHPA. I'm also the chair of the EHPA Research and Innovation Committee, and I will be moderating the session today. This session is actually organized by our communications team. And as you might have seen from the social media and the communications that EHPA does, the communications team has a lot of these events, very interesting events, and I very much encourage you to participate in the ones that you find relevant and informative for your work. As I said, feel free to ask questions in the GoToWebinar chat box, the question tab, anytime during the session, anytime you have something popping up in your mind. My colleague working in the back end of the platform, and we thank the colleagues that are not seen, but their work is very much appreciated. We'll gather the questions, and we will have the possibility to ask the speakers today. Just a short introduction about today's webinar. Basically, let's be honest, high-rise buildings, especially very high-rise buildings, I'm pretty sure we all appreciate them. It's still fascinating to me, at least, that for thousands of years we've been trying to get towards the sky, right? The Pyramid of Giza was the highest structure for 3,800 years, only surpassed by a cathedral in England I think 1,000 years ago. And then we are here today with the skyscrapers, with the buildings that we live in, that show evolution, revolution. It shows economic strength of the country and the city that they are built in. It shows the population density of a certain city, its success. And lastly, but not less importantly, high-rise buildings serve as test beds for the energy transition, for the innovative technologies that are coming up in that field, and are a showcase of what can be done with the technology that we have and with the perseverance that we all benefit from. Now, just a short background, as you might know, 75% of buildings are still heated with energy from fossil fuels. Heating buildings is responsible for 20% of final energy demand and 14% of CO2 emissions. Not to mention the ever-increasing cooling demand that we all know and unfortunately have to live with. A large share of buildings in existence today will still be here in 2050. Hopefully a lot more after that as well. In consequence, and in relation to this, renovating them, taking the time to renovate them correctly, making the right decisions now and in the short to medium future will have tremendous effect on the capabilities and on the impact on the climate that we all are trying to avoid. Now, of course, the European Commission has recognized the importance of buildings for a decarbonized Europe and has announced, what many of you know of already, the Great Renovation Wave as a key initiative in the EU Green Deal. And let's be honest, given the recent developments, as a key to the future economic recovery of our continent, businesses, and society. So meeting the challenges of decarbonizing the building stock requires dedication, it requires ambition, and requires, let's say, people to take chances, to work hard, and to make real, palpable progress in this field. And luckily, we are joined today by three such individuals, and again, very thankful for their participation and for their positive response to our invitation to join us today in this webinar. Now, starting in no particular order, Andreas, I would like to. It is my pleasure to introduce you, Andreas Kahr, heat pump business manager. Raised his hand. Very good. Vaillant Group, Austria. After studying sustainable energy systems, Andreas has been dealing with heat pump systems for almost 10 years, initially as a classic product manager, later working on research and development topics. Today, he's responsible for the heat pump business in Austria, facing an interesting market environment where all disciplines come together. Thank you so much for that introduction, Andreas. Moving forward, again, it's my pleasure to welcome Martin Betz, Technical Director, HVAC Systems, Glen Dimplex Heating and Ventilation. Martin has more than 30 years experience in development of products for the domestic and commercial heating sector. Since more than 10 years, he's focusing on renewable technologies in the UK and Ireland, such as heat pump technology, solar thermal, solar PV, and low temperature heat emitters. GmbH has developed a new innovative heating and cooling solution for high-rise residential building and new build and retrofit environment. Thank you so much for this introduction as well. Moving forward, and again, a pleasure to introduce you to Sebastian Bangheri, Sales International at Heliotherm. Sebastian has been working for Heliotherm for the past 8 years. He has an impressive and diverse background, having worked in the heating and installation business, manufacturing of oil boilers, and even as a mechanic on large ships in the North Sea. That's really impressive and a diverse experience indeed. He has an extensive experience in R&D, designing new gas absorption heat pumps, 3 years experience in that, and technical sales team support in calculating heat pump designs. This heavy technical background is beneficial to his current position as Sales Chief International, where he has the opportunity to conduct large-scale products with air source and ground source heat pumps all across Europe. Now, we will have to talk about your time in the ships in the North Sea, but that is outside of the scope of this webinar. Tune in next week for that. So, now that we've gathered here, we have the introductions all sorted out. We know each other. We hopefully determine that we all can see and hear each other, and that we are all well, hopefully again. Let's get down to business. And I would start with something on everyone's mind, unfortunately. A question for all three of the panelists. Because of recent developments that will not be named, a lot of economic activity, industrial activity, and so on has stopped because of the government's imposing lockdowns, people working from home, and so on. So there was a steep reduction in CO2 emissions. However, this is due to very, let's say, specific circumstances. But I would ask, let's start with Sebastian. What can we do to maintain this decline in CO2 emissions?
Yeah, I think that in general we should put some more funding into research and development projects like we had in the past, which some are still ongoing to reduce this. And also we have to put some funding towards the public that they acknowledge this technology as being good in terms of heat pumps, to reduce the CO2 emissions. And we as manufacturers also have to see that we manufacture our products in a way that it is more or less CO2 neutral, not that the production uses a lot of energy, that the product becomes actually basically not very good. Maybe like there's a discussion going on with the batteries, that they're not so economical in real life. So I won't give more opinion on that. Everybody has his own opinion, but that would be the case.
Yeah, exactly. What about you, Martin? What do you think about this?
Yeah, well, the reduction CO2 came mainly through a lower economic activities across the world, across Europe. So to take that, we obviously need to reduce dramatically CO2 emissions. And I think, we are together here this morning talk about heat pump applications, and the Europe and the governments have introduced or announced big economic programs to help the economy go back. So those programs, they need to be aligned, totally aligned with the reduction of CO2 emissions and introduction of sustainable solutions. So this is, this needs to be, and the renovation wave and all the vibes we hear from Europe are correct. But I think we need to get down to business and actually do those things. We need to work as a collective from architects, from renovators, from builders, as manufacturers, suppliers of solutions, on this aim of introducing solutions who actually work, which actually work. And yeah, we need the programs be aligned, the financial programs for the economy be aligned with that goal.
Yeah, very good points, of course. Andreas?
Yes, I also fully agree with Martin's opinion. In my thoughts, we need to really have clear green ambitions to recover economy in the next months or the next years, and we all together have very big ambitions to reduce CO2 in the European Union. And I guess we have now the chance, the one-time chance, to really create a big wave in case of modernizations. The industry is ready to implement systems. We are working in modernization since many years, and we have the solutions to place it into the market. And we need to discuss with others, policy makers, with fundings and so on, to open the door for heat pump solutions in modernizations. In different countries, it's a different way to look on heat pumps, but heat pumps of today are fulfilling the complete range to place them very high efficient in modernization, and that's the way we are working on. And yeah, we need to accelerate our modernization wave.
I wanted to add something to Andreas' point. Ambition, I think, is very important, that we have high ambitions. Together with the ambitions, I think we need clear plans, stepped plans. How many buildings we want to renovate, what is our goals in CO2 reductions, clear plans, clear guidance. I think everybody wants to do it, but I think we need the governments and we need Europe to lead the way, to give us a way. We will follow. We as manufacturers, if we have clear guidance, we will innovate, we will come up with new solutions, we will apply them. The architects, the developers, they will apply them as well. We need, together with the ambitions, we need clear guidance how to achieve those ambitions.
Yeah. And an alignment of the actors involved, I would say, and you touched upon this. Who would you say are the most important actors for the ambitious goals that you're setting out? How can we get them on board? You touched a little bit about policymakers making plans. Are they the most important actors that we have to deal with How do we get them on board of our ambition? Let's say, make them partners in our work.
I'm not sure whether there's the one important actor here. I think it's a collective. It needs to be a collective effort. Obviously, politicians are important. Governments are important to give the guidelines. But on the other side of the spectrum is the end user. The end user is equally important. His goal is to have a more efficient heating, cooling system, a more comfortable home, and all the people in between, whether it's the architect, whether it's the equipment manufacturer, whether it's the installers, the plumbers. We need to bring all the actors together, and they all play an equal important role. Because like a gearbox, if one of the smallest gears is not working, it doesn't work. So
exactly.
We need to make sure that this gearbox is oiled very well. And we need to bring all the actors together. Education is certainly a big issue. We find that architects, specifiers, consultants, they don't know what's available. The end user doesn't know what is available. The end user doesn't know what he could get, how well he could improve his home. So education is a key thing. And finally, I think finance. I think there's enough money out there. Just need to be again guidance rules how to tap into that finance.
Yeah, fully agree on Martin. Also, what I think addition is to don't forget the end users, because the end users are the ones who are acting and say, okay, I want to change my heating, replace my old heating system. I want to go for a heat pump. And we also on our side as industry, we are very focused on give the customer the confidence that our system or a heat pump system is working very well in modernization, and we have a lot of benefits instead of different to creating, working on radiators, working on underfloor heating systems to go more in deep maybe. But we need to have the biggest thing is the end user also. Don't forget that this people, because they at the end they have to pay the industry, and this is also a big challenge to give them the good mood that they're doing a good thing and then their system is working very well. That's very important, I guess, too.
Exactly. So all along the value chain, from of course, the user, from the design, from the manufacturing, from the way it's communicated, from the way that the installer is trained to install the heat pump, from the way the user has the relevant information in their hands to choose a heat pump and to know the advantages of it, because ultimately, I would think you would see the user as an ambassador for the product, right? If the user has all the information, puts the heat pump, and is happy with the product, for sure that he or she would be, they would act as an ambassador for the technology and share the knowledge to their neighbors, to their friends, family, and so on.
Yeah.
But sometimes we do get, and this is a controversial question, let's say, we often hear that heat pumps only work in new buildings. Renovation is difficult. You know, it's a hassle. Might as well use the same heating product that they've been using before. They need the product now. They need something that they are used to. How would you answer that, Sebastian? That it's only for new buildings?
I would say that's not correct, because I can just give you a typical example. Our building, or my father's house, is from the 70s, and we got air source heat pump there for many years now. Of course, we did a little bit of installation outside, but I say it works very good, and it's also only on radiators running on a lower temperature, you know, not on 70 degrees like it did in the past, but on 45 right now. And yeah, we were actually never cold unless it went like -24 outside, which sometimes happens, but then you just have to take shorter showers. So yeah, I say it's okay. You just have to be careful that the radiators are sized okay and that the pipes are sized okay throughout the building. But this is typically on the installer, you know, that he can fit it for purpose. But the units are definitely capable of doing this, you know.
Dan, I think your question is actually wrong. Your question is the wrong question to ask. We should ask ourselves, what do we need to do to take heat pumps into renovation? How can we make heat pumps in renovation work? You know, Sebastian just gave a good example, but what he has done is he has reduced the heat loss, so he had reduced the flow temperature, so he could apply the heat pump technology. You know, with the ambition. We don't have the ambition to bring heat pump technology or other clean technologies into the renovation sector. The only choice is keep using fossil fuels, and we know keep using fossil fuels will not reduce the CO2 emissions. So, you know, saying heat pumps are not suitable for renovation doesn't solve the problem, doesn't add anything to the discussion or anything positive. So the question needs to be, what do we need to do? Do we need to change the heat pump technology? I think no. I think we have the heat pump technology. Next question is, how can we apply them? Do we have to? And certainly on high-rise building, the topic today is, I think heat pump technology needs to be slightly differently applied. There's no new heat pump technology to be developed, I think, but as such as refrigeration circuits concern and so on. But it maybe need to be applied differently. And what else do we need to do that the heat pump actually achieves the goals in a retrofit situation? Okay.
Yeah. Yes, and at the end, we show in many cases in Austria, for example, that the heat pump works very well in modernization, also in a multiple family house, which we hear in a few minutes. And yeah, we are saving lots of CO2 with the heat pump machine in modernization, and we keep the safety and the economy, the comfort in each house. This is also a big point on that. And yeah, we know how it works and keep all together and start the wave, let's say.
And then we need to record this webinar and then disseminate it as much as possible so that some of these, let's call them preconceptions, disappear and are replaced with solid examples like Sebastian put, and this is how it works, with solid planning, like Martin said, with involving all the actors, as Andreas said as well, of course. A lot of work, I have to say. You have a lot of work on your hands and on ours as well. And thank you so much for this very lively discussion. Now, as the participants would know from the agenda, there's also, the speakers will also have a 10-minute presentation each, and it will bring more information from to complete the discussion that we just had, as well as serve as the discussion topic that we will engage in after their short presentation. So each presenter will present for 10 minutes. We will start again in no particular order with Andreas, who will present mini heat pump innovative solutions for new build and modernization in multiple family houses. So I leave it to you, Andreas.
Okay. Thank you for the introduction, Dan. Yes, my name is Andreas Kahr. I'm working for the Vaillant group in Austria, and I'm the heat pump business manager responsible for the heat pump business in Austria. And today I want to introduce innovative solution for multiple family house in a short way. As Vaillant known, we are producing heat pumps for every building, kind of building, for more than 20 years. We can offer a lot of different solutions, starting from the left-hand side with a wall-hang domestic hot water heat pump. We have our Flexotherm serving all three kind of heat pump sources together in one machine. We have this our Aerotherm machines facing a lot of also in renovation, very strong outside heat pumps, of course. And of course, on the right hand side, we have also indoor machines air water heat pump machines for the inside. And yes, and the current situation on heat pumps in apartment buildings is, yeah, the classic centralized solutions based on ground source heat pumps or on air source heat pumps, which are well known and good established across Europe, I guess. This is not the complete innovative way, but now we have a new situation and a new solution offering now in Austria, for example, and also across Europe. We have a mini heat pump, which you see on the right side. It's not a gas boiler, it's really a mini heat pump. It's a fully equipped heat pump with a complete cooling circle, and also the complete heat distribution and control unit is placed on a wall hang machine, which is the same size as a gas boiler. So, and why do we need this such an innovation in a multiple family house? As I said at the beginning, for in Austria, the modernization wave in multiple family sector is below 1%. We are facing 0.8%, which is very low at the moment, but we have very high ambitions to recover and to reach our 3% target for the next years. And so we found a solution, or we take a step back, talk with some shareholders, with city owners, and we need to install or to implement or to look for a solution for modernization and also for new build our high-rise buildings in the cities or in across Austria. So we comes up with a new innovative way for each flat, especially for the cities in this case. And according to the Renovation Wave, which we stand in front of that, we can really say that the heat pump is the easiest solution to fulfill the complete building requirements on the modernization, also on the new build sector. And at the end, the last point is that we create a unique solution which allows us a stepwise modernization for each building, which means that you can implement a system, and after all the flat owners say, okay, I want to change now, or I want to change in 2 years or in the next year, I can really stepwise modernize each building. So I try to cover my mini heat pumps on one project or stepwise in phase of 2 or 3 years. And what also is very important on that, it's a multi-source heat pump, which means that beneath the classic sources, which is air, water, or deep drilling, we can also connect low X microgrid, which means low temperature district heating. This is also a very innovative way to run the heat pump with district heating water. So now I want to introduce the easiest solution, or the most interesting solution. It's the solution with an air source heat pump as a source. On the point 1, you see it's the heat pump Flexotherm with Aero Collect as a source on the outside, which is basically placed on next to the building, in the garden, or also on the roof of the building, which is supplying or producing very high efficient 30 or let's say 20 degrees in the buffer tank, in the heating room in the basement, and for distributing the source through all the buildings in the flats, we are using, for example, the old gas supply through the buildings, or we use old chimneys or whatever. So we bring back very high temperature, or very high 20-degree temperature to all the flats, which allows us that we run the mini heat pumps in the flats with a very high efficient level, and we can provide for each flat heating, passive cooling, and domestic water at the same time, more or less. Also for the decentralized domestic hot water solution, we can offer a wide range of different solutions, which we're facing on depending on which space is required, or where can we place the heat pump. So we have really lots of different solutions to realize the system in each flat. Furthermore, we are allowed, or it's also interesting to place a photovoltaic system to provide electricity to this house, to reduce also more or less the CO2, and also to supply electricity directly to the machines. All over, we can cover the system with an intelligent controller. We are able to connect the entire system to our service department, where we can see, okay, this heat pump runs, we need to have maintenance on there, or there is a problem. Then we recognize this in our service department and can contact the customer to see how it works. So then I also want to try or give you an idea, how does it work in real? I introduce a project in Austria in modernization. We are modernizing a building with 12 flats. This 12 in this building, they really put out the gas connection. They put out all the gas from the building and they place a heat pump. We have 12 flats. We are using for the heat distribution in the flats the existing radiators, where we show the case that modernization is working very well, also with radiators. For domestic hot water, we are placing 150-liter tanks below the dishwasher, which is very important because on the space, you know, in modernization, the people don't want to give a space of the heating system anymore. So we need to discuss and find the right place or the perfect place to place the system in the flat. And yeah, how does the source for the heat pump comes into the flat? As I mentioned before, on the roof, in this case, you see this red on the top. On the roof, we place the Flexotherm and the Aerocollect, which is the air source heat pump. On the roof, we have the heating room. We supply with the distribution lines in the chimneys and in the old shaft of the gas connection, and distribute 20 degrees through these shafts directly into the flats. And so we can guarantee a very, very high yearly efficiency rates according to different other systems. And yeah, at the end, it's very, very interesting. We save a lot of CO2, around 40 to 50% in this case. And yeah, it's a very interesting project in modernization. And yeah, this is the modernization project. Then I want to introduce also a new build project. It's also in Austria. In this case, it's a nearly energy autonomous village, which are, they have very intelligent system placed here. We have 62 flats in this small village, also supplied by mini heat pumps for heating, passive cooling, and domestic hot water. Each house, there are 6 in this village, gets an PV system on the roof, which supply the electricity directly to the heat pumps to run the heat pumps, also supplying charging stations for the cars. And all over the entire system, we have an intelligent system management together with a partner to maintain and to run the entire system most efficiently and nearly energy autonomous. That the heat pumps run direct with the energy from the sun, and of course the domestic hot water preparation, all the things which are coming together were maintained and controlled via this intelligent system. So yeah, this are my 10 minutes. I just want to summarize the small the system highlights of our mini heat pump system. Of course, it is a wall hang heat pump for heating, domestic hot water, and passive cooling for every apartment. Then we have, with this system, we have very high CO2 savings due to our innovative and intelligent energy concept. And this is for me the most interesting way for urban areas. It's a multi-source heat pump running on air, running on geothermal energy, running on groundwater, and also running on low-X district heating, which means we can really connect also the extra heat from industrial processes, where we also can take this energy to run our heat pumps, which is also very, very interesting on that. Then, of course, it's the solution for new buildings and of course for modernization. This is also very, very important on that. Yes, as I mentioned before, we have a very high sustainability. We reduce the ecological footprint for each flat by also the further benefit we reduce heating costs for each flat, which is also very, very interesting. So what is also possible, we can also create heat pumps with together in a hybrid system, which means that, yeah, for example, bigger flats or bigger systems need to have additional energy sources, or have a hybrid system with, for example, with a gas boiler. So we are also able to connect the system to hybrid and also to get higher output rates. This is also possible. So the next one is we have a minimal space requirement for each flat, which is in renovation very interesting to talk to all these stakeholders. And of course, as I mentioned before, we reduce the heating costs for each flat. And of course, it's very easy to operate a decentralized system for each house owner. And this makes the system very, very interesting for house owners too. And of course, we are working on several projects at the moment. And yeah, looking forward for your questions, and thank you for the time.
Thank you, Andreas. Thank you so much for the very informative presentation. To be honest, I do have a lot of questions, and I'm sure the audience as well. However, I will hand the floor to Martin as the next presenter. His presentation title is Heat Pumps in High-Rise Buildings, Tower Blocks in Manchester, Edinburgh, and a New Type of Heat Pump in Holland. The floor is yours, Martin.
Yeah. No, that's not mine. That's Sebastian's. But
no problem.
I can present mine now, if you want. So I want to present our Zeroth energy system. Zeroth energy system is probably not that dissimilar to Andreas's presentation, but we looked at high-rise buildings and how high-rise buildings are currently heated, how they were heated in the past, and if we want to develop a system which uses sustainable energy, how that system would look like. To give you some background, context, the current systems, they either have heat interface units and a high temperature loop. And to do this project, we went out to developers in London who are actually developing high-rise buildings and have done that for the last 20 years to get their input. Because I don't think if you talk about renovation, you need to apply your technology to the house which is there. You can't apply a technology and then make the house totally fit. Sometimes you have to repackage maybe technology to fit the house. And so current buildings, they're using high temperature heat networks or gas boilers, individual gas boilers, or electrical heating. They're based on many times on fossil fuels. And particularly in London, there are some heat networks. In Denmark, there's a lot of heat networks. In Holland, there are a lot of heat networks. But when you look at heat networks in a residential building, you see that losses on those high temperature are phenomenal high. And the British research establishment, BRE, has done a study back in 2016, and they found high distribution losses of those systems in residential buildings, up to 66% losses. So 66% losses, 66% of the energy which were put into the distribution loop in a high-rise building was lost. Now, if I replace that one-to-one with a heat pump technology, I'm still losing 66%. Now, individual heat pumps in each apartment will not work. Those heat pumps in individual apartments, we can't fit them. And central heat pumps for high-rise building and distribute then the temperature. As I said, you still have, if you have high temperatures on the distribution loop, you still have high losses. So looking at this, we came up with a relatively simple solution. and similar to Andreas' solution, when you want to reduce losses in a heat distribution network, if you reduce your temperatures in that distribution network, number 2 here, to ambient temperature, and ours is running at 25 degrees, you take all the losses out. When you do that, you need to give the energy a temperature lift in the apartment. Therefore, we have developed a heat pump for each individual apartment, which can do base heating, hot water, and cooling, active cooling and passive cooling. I come to the challenges in a few minutes, but this design is ideal for new build. This design is for retrofit. It actually fits the demands for the developers because they are used to heat networks. They don't have to change. They have to replace the heat interface unit now with a different unit. But otherwise, the same rate, the same design concepts can be applied. In terms of central plant, they can still connect it to district heating networks. And an interesting fact about district heating networks is there was a Horizon 2020 project across Europe, heat roadmap. And one of the findings was that we are wasting across Europe in terms of low waste heat, in terms of air conditioning, in terms of power generation, enough energy that we could heat Europe. So I think the aspect of district heating or low X district heating is very relevant here in the transition to a sustainable world, because the energy is already there. We just have to use it. And this, I show that in the next slide. On the right hand side, you have a lot of energy sources which you couldn't have with a high temperature heat network because you just couldn't harvest that energy. Waste heat from transformers, from data centers, from landfills, connect to mine waters, connect to sorry, I have just a second. Laptop is a bit okay. Wasted to sea or to rivers. On the left hand side, you have more conventional heat sources. You can use gas boilers or CHP units if this is what you require, or if this is as a peak load gas boilers. But you can now introduce air source heat pumps, ground source heat pumps. Connection to the district heating is still possible. Another interesting aspect is the introduction of store. Everybody talks about battery technologies and how we can store intermittent renewable energy in batteries. But with a system like this, you can introduce large stores in the basement, very low cost-effective stores. You store the energy in 40, 50 degrees. Your losses are very minimal. And your store medium is water, so it's very low cost store. In terms of the challenges we had to overcome, it's easy to envisage that one of the key challenges is space. Whether it's new build high-rise building or whether it's retrofit high-rise building, space in those small apartments is certainly at the premium. What I show you here is a utility cupboard, which could be manufactured for new build offsite, but in many cases, a lot of apartments, traditional apartments, have a small compartment similar to this. And you see the unit on the right-hand side. This is a heat pump. We can provide retrofit situations up to 9 kilowatt heating load in a footprint of about 550 by 550 millimeters. This is the footprint of a traditional hot water cylinder. This is a footprint of a width of a traditional heat interface unit. So the key thing here is, and working together with developers helped here a lot to focus our minds here. The key thing is that it has to go into existing spaces. can't create new spaces. If you need a larger footprint, you can't go into where the original cylinder. You can't go where the heat was. So space was one of the challenges we had to overcome. The second challenge was obviously noise. We're putting now up to 9 kilowatt heat pump into a residential area in the middle of an apartment. And just to illustrate that, I have this slide. You have a cupboard here, a double cupboard here, and that's where the utility room is. It's just beside the dining area in a small apartment. So noise is absolutely critical. We had to meet basically the same noise levels as a modern fridge. Otherwise people wouldn't accept that. As I said earlier, you need to bring also your end consumer onto this journey, and he has to be happy with the system he ends up with. When I open the doors, you see the unit here. In this case, I'm showing you also the fan coil here. So with that system, we can heat and cool. Cooling is quite often neglected, but those high-rise buildings, they are overheating. They need to be cooled as well. Customer comfort need to be addressed. Okay, I'm aware of the time. When we did develop the product, we also did an overheat study, because that was one of the concerns we got back from the developers, that the existing solutions and the existing buildings, the older buildings with heat networks, are dramatically overheating. So we took a building, we modeled it up, and we did CFD studies. And what you can see here, with a flow temperature of about 75 degrees, you are creating corridor temperatures in summer and in winter of around 30 to 35 degrees. Recently, people have introduced ventilation, purge ventilation, which basically try to cool down those corridors. The purge ventilation is only wasting that energy. So therefore it's not really a solution. We have modeled in the same building after we applied the Zeroth energy system. The temperatures of the corridors just dropped down to around, in summer, to about 24 degrees, and without ventilation. And in winter, actually, there's heating now needed in those corridors, because there's no temperature losses from the heat network, and therefore it's cold. One of the issues applying this technology, and I think that we didn't discuss it on our earlier discussion. When you have a solution for a problem like that, you still need to apply it, and to find somebody, a developer, a building owner, to want to apply a new innovative solution is quite difficult, particularly if it's multi-residential. Maybe it's 100 apartments, 50 apartments, 200, 300, 500 apartments. Therefore, we had to build a test center, a test bed, just in front of our lab, where we have simulated the system in a 8 apartment block. You can see here on the right hand side on top, we are serving that little building with the SOC pumps and little plant room. To demonstrate that there is no losses, we have used actually copper pipes, bare copper pipes for the distribution system. And with this way, we could persuade developers, occupied owners, to test that system and to introduce that system. And that's my final slide now. We have first installations now of that system in the UK, in London, and in south of England. The first installation, which I showed you here, is a new build actually. You have on the roof 4 60 kilowatt heat pumps. We have the buffer vessels and stores in the plant room. And this slide here on the right hand side shows you a small little space. The cupboard, or the room, the utility room where the washing machine is in, and our heat pump integrated with a cylinder is only, the room is only 10 centimeters wider than the unit. So there's no space, and it's it's possible because the unit is so compact, and that's it was a key criteria made this building possible, and which we also now working on a number of renovation projects coming through. But it's one final point I want to make is it's difficult to, when you have an innovative solution, that you actually get it into the market, because people try to do what they always know, and that's where we need also help to de-risk those solutions, to the application of those solutions. Okay. Any questions? Yeah, please send them through to the panelists. Okay.
Thank you so much, Martin, for the presentation on Zeroth Energy Systems. Of course, there are a lot of questions. We'll just move to Sebastian's presentation, which I told before by mistake. I'm so sorry about that. Heat pumps in high-rise buildings, tower blocks in UK, Manchester, Edinburgh, and a new type of heat pump in Holland. The floor is yours, Sebastian.
Okay, thank you very much. So I'll look at the time, and I'll just start right now. So this is our factory in Austria, where we produce all of the units, and there is only this one. The building is quite new. It's like 10 years right now, and the company is 32 years in total old, but I'll not keep too much with that. Okay, so I'll start with heat interface systems for tower blocks. As my colleague mentioned from Ireland, that there is a problem, you know, if you distribute high temperature throughout high-rise and low-rise buildings because of the heat losses. And mostly in the 60s, they didn't really insulate the pipes very well. So it is true that it is overheating in summer, and we have a lot of heat loss in a typical building, you know, for let's say 50 flats, it's 3,000 pounds where you have only heat losses, you know. And this is very negative, but I won't hold me up with this too much because it's very similar. So here you can just see how it is, you know, that you have to circulate actually 60 or 70 degrees throughout the building all the time through a plate heat exchanger, and then basically distribute it to the flats. So this is very inefficient, and it's not very positive to do it this way. You know, this is like the old times that we used to do it, but we have to fix it. There is also possibilities of putting, you know, heat pumps outside instead of connecting it to the mains gas or district heating system. But it's no point of putting in systems when you still run the distribution in the house at high temperatures, because the COP of heat pumps is proportional to the temperature. So the higher the temperature, the less COP you have, and that is not very good to do. So I came across a few projects recently that they wanted to do it, and it's not very good. So what we are proposing is that we cut out these systems. As you see, we don't have like high temperature circulated throughout the buildings, and we don't have any heat interface units that are also quite costly. You know, when you compare them, you can buy them for 1,500 euros. And this also brings up the price if you would combine it. So our benefits are no billing platform for the landlords, no billing platform for the residents, no flow meters, no external plant room, and the pumps are not running 24 hours a day, which also consumes energy and produces also waste heat actually. And the distribution heat loss is also very low, because either we distribute the water at a low temperature or the same temperature as the building, as you can see here. What we do is we go in with the pipework directly into the building, and usually that is at around 8-7 degrees, depends on the year, period of the year that we have, and then we run it throughout the building. There is also the possibility of building in a booster heat pump in the basement. If you have a retrofit building and you cannot insulate the pipes, if they're old steel pipes, then you boost the temperature up to 20 degrees. So then there is no temperature differential in the building, and this saves a lot of money for installation. You don't have to rip up any walls or corridors, and so that's the two possibilities that we do. What we also do is we have our, it's called SMS ground source heat pump. That stands for Smart Module Solution, because the SMS, you can have it as ground source, air source unit, and it's a very clever solution, and we do this with a lot of customers in the UK. So basically, when you take off the covers from the unit, this is what the unit looks like. We have a small heat pump on the top, which holds all the refrigeration. In the back, it has the circulation pumps inside, and in the front, you have the electronics. And below, there's just a standard hot water cylinder with a coil, you know, which, you know, like some countries like Holland, they want to use their own. Some people in the UK, they want to use their own. Some people in Spain, they have their own hot water tanks that they like, so we leave this open to the client. And what we can do with the unit is we can heat a radiator, like in this case. We can also heat underfloor. There is also the possibility of cooling with the unit, but this is not going to be discussed in this presentation. Right. I'll start right now with my actual case studies. So we have two cases. We have either ground source units or air source units, because I don't want to favorize one or the other, because it's not fair to do this, you know. So last year we made a few flats in Edinburgh with a big unit of ours, and that is the simplest way to do it, because it's very tight to, you cannot drill, and it was very good. So one of our 55 kilowatt units is making like a district heat system, and the district heat is distributed throughout the building, you know, like you can see on the left-hand picture, there's one buffer tank for heating and one buffer tank for hot water. So this is like the more simple version that you can retrofit anywhere into any building that you have. There is no special installation on the building, just it's got already underfloor inside, and it's already got hot water cylinders in the flats. So this is like the out of the box solution, where you can say I have a building, I need a heat pump, and you put it in and it's fine. So this is the quickest way to renovate something, is with air source units. So this is our air source units split version. This is a simple hydraulic schematic which we provide to installers, planners, and architects. Not very hard to understand. And this is the even simpler version for the customers. We have a 60 kilowatt monoblock unit where you don't need any F-gas certifications. So if you have bigger buildings, you can put multiple cascades of, for example, 5 there, and just heat the building tower, the building block with this. So this is the simple air source solution that we can provide. Now we come to the more complicated solution of mini heat pumps, same as my colleague mentioned before. And we did in Manchester tower blocks, and each tower block has like around 100 flats. Some have 80, some have 130. So there's a lot of things to conquer in these buildings. So one, they are very high. Two, they are very old, and everything on them is made like in the 60s, 70s. So it's very a lot of work to do there in building renovation. You have to put new windows, put new insulation, and also make a lot of adjustments in the building, you know, also with the radiators. But it pays itself off, you know, because we spoke about CO2 reduction, and as you can see, the heating cost was 700 to 1,100 pounds per year for the residents, and we brought it down to 140 to 340 pounds, depends how much the resident heat their flats, you know. So that is a cost reduction of, let's say, 70%, and also a massive CO2 reduction. By the way, this was electric storage radiators, if somebody wonders what it is. So this is what the units look like when they're built in. This is the electrical cupboard that is very typical for tower blocks, you know, in Vienna, Berlin, all over the world. And the unit is made to fit into a 60 centimeter door. The units are quite narrow, they're only 54 centimeters. So you can actually fit them in any normal door that we have across Europe. This is what the units look like in production. So they are mass produced, they're very small. They already come, everything is pre-adjusted. You just put in the cable, flick it on, and it's already got settings in it so that you don't even have to do any settings anymore, because the commissioning consumes a lot of time. So that's not so good. So we do actually the pre-adjustments for the clients. Typical layout of the flats. This is the distribution of the riser system in the flats. So we come up with a big riser pipe and go down the other way again, and then we tee off with 28 millimeter pipes. So then we have a hydraulically balanced system. The bore field was done on the parking lot because it's always the question of place. In high-rise buildings, we don't have any space for air source units on the roof because we would have needed here 600 to 700 kilowatts, and that would have been too much weight for the roof and no space available. So the ground source solution is more costly, but it's a reliable energy source, and every tower block has a parking space around the building. So this was the best solution to do it without having extra land, you know, or something, because it's always the question, we don't have any space, but there is space, you just have to look for where it is. And what we also used is a special bore probe made of carbon fiber. It's not traditional because we save around 50% of the bores needed. We only have 17 or 18 bores in versus 40 to 60 with conventional bores. Yeah, that was drilling on the parking lot. So, oh yeah, that was the drilling of the next building. It looks quite similar, but it's even more. It's 138 flats. And we also were very successful at that one. This is the units. They are being finished in the UK over there before they're shipped out to site. And these are 3 different tower blocks where we have, you know, the phases of renovation. You know, you put up the new installation. Then in the middle picture is with the new installation, and the right-hand picture is when it's with the new cladding outside. So it also gives a fresh look to the building, you know, because the building is from the 60s, 70s. So then it looks more nice when it's finished, and everybody can see that there's being renovated buildings. And this is for social housing, so it also brings a better quality to the life of the people there, and they have environmental friendly heating, you know. That's the main point of it. Yeah. Okay, this was the presentation. I'll not take too long right now. I'll just show you. Can you see my screen?
Yeah.
Yes.
Perfect. I'll just show you, because of connectivity is very important. So we have all of the units online. So I'll just show you the units right now, because it's very important that we can service the unit. You know, if a unit goes into error, we don't want to disturb any resident. We fix the unit on the internet, or the service technician does, and that's it. So this is also a benefit that we really have to appreciate the residents' privacy, and we don't want to go there anymore. So we can actually fix anything from here. If you go to data points, you can see the temperatures and anything from inside the unit. We have over 400 parameters that we can control here. So if we need to fix anything, we can do it online, and this is also very good benefit. And also what there is that for the future, we are talking about microgrids and connectivity with the electricity providers, is that in peak times between 5 and 8 at night, we can basically reduce the whole tower block with the heat pumps, because these are inverter units. So we can reduce them to a minimum consumption of the heat pumps, but still have enough heat for the residents that they don't get cold. So this is also something in the future that we have to consider with heat pumps, is that we have to work together with the grid providers, the electricity companies, to also save CO2, because at peak times we produce a lot of CO2 with the fossil fuel backup electric generation, generators. Yeah. Okay. So thank you very much, and I'll hand back to Dan. Sorry, I was a little bit over this time, but it's 10 minutes are tight. Thank you.
It's okay, Sebastian. Actually, you've answered the question that was asked about servicing the heat pumps via an online connection. So
yeah,
you've actually saved some time doing that. Thank you so much for all the panelists for their presentation. A lot of information to take on, but I must say, just looking at them, the heat pumps look very good. There's, from a design standpoint, let's be honest, the requirements, the space requirements are taken into account and so well designed into the product. The noise and everything related to it, the testing that goes on that you touched upon, the way that they're already integrated in projects, and with replicable results, right? So you put them, and all of them can be scaled and can be easily replicated. I also saw a lot of mentioning about the role that the end user has, about the building owner, about the design of the building and taking into advantage. Andreas showed the building and how they were taking advantage of the chimneys, of the shafts and the infrastructure that is already there. So basically, I would say that that heat pumps are not only the feasibility of the technology, but they are well tested. They look good in the renovated building, and they have they are visually appealing even. So what would you need to scale this renovation? Andreas was talking about less than 1% in Austria. He would want 3%, but how much would we need actually? What is the percentage you would need?
What would we need? We need much more than 3, I guess. We will need 5 or 8%. We have in Austria, for example, we have 600,000 oil burners running. And when I thought we have now a new government with clear ambition to renovate our bases and to go on these topics. But let's say, for example, when I have 600,000 units until 2035, which means we have 15 years to change for each year 40,000 buildings. So these are not only multiple family houses, but they're only single family houses. So we have a really tough job to do in the next 15 years. And in this case, I'm really open to bring all the people, all the stakeholders onto one table and to discuss how can we improve or how can we accelerate our economic or recover our economic, not only in Austria, I guess in whole Europe. So it's really tough to get this progress. There are also not heat pumps on the market, which we also focus on, because there are also biomass on the market. In Austria, for example, the biomass lobby is very strong. We have good fundings for bringing out the oil from the single houses. But the focus is at the moment only on the single houses, but we have also keep an eye on the multiple family buildings in Austria, just when I talk of Austria. So yeah, we really need to talk, to bring all the people together, to talk also to the city planners. What are doing they? What is the potential of the city, or how do they think? So we need to discuss all together and find the right solutions and or the right energy mix to reach our targets for CO2. It's a very important point, I guess.
Yeah, and we need to, for sure, to get the end user on board. I mean, they would be already on board if they would have all the relevant information, all the examples that they are tested. This is working. We've been testing them, or all our products are available, tested, and easy to use. What would you think, Martin? What would be what can manufacturers do more to convey this information to the end user about the utility, about the easy of installation, the easier way of installing them, and so on?
Yeah, I don't know what the manufacturers can do more. We obviously run workshops. We are running already information events to educate the end user, to educate politicians. I think what's needed here is that people actually stick to what they say, the ambition to change this, the ambition to transition from a fossil fuel heating world to a clean energy heating world. I think the presentations and today's webinar, I think, has demonstrated that for high-rise buildings, the heat pump technology is adaptable, that manufacturers are coming up with solutions if the problem is put to them. One of the key things is this de-risking of new innovative solutions. We find it incredibly difficult to convince people to try something which hasn't been tried too often. Now we are getting there, but we are getting there far too slow. I said it earlier, we need a plan, and the plan needs to come from Central Europe or from the governments, that we need to renovate. There's 70% of the buildings, or 75% are still heated with fossil fuels, or maybe more. In the UK, it's even more. And those need to be changed until 2050. There's not that much time anymore for that. So we need to collectively be quicker.
Of course, planning, involving all the stakeholders, hopefully having a plan that takes into advantage all the work that you've already done, because you come with the examples, you come with a tested solution. So a continuation and building on the work that you've already done. Sebastian also touched upon the cost aspect for the end user, especially in social housing. Because cost, of course, is a factor for the end user. Would you want to say more about this, Sebastian?
Yes, I think this is very important, because it is these people, they don't have very much money, and it's very controversial that those people who don't have much money pay the most for their heating currently right now. Because the people who have a lot of money, they buy them a fancy heat pump and put that outside of their, in their garden, and then they have really cheap heating. But of course, when you look at socially not so privileged people, then it's very difficult, because you pay a fortune for heating. I mean, I can give a good example. In my old flat, I had to pay 1,100 euros per year extra on top of my monthly 200 euro heating bill, because there was a oil burner inside running at 70 degrees all the time. And that was the point where I said, okay, I'm spending all my money for heating. I can't go out with my friends or buy whatever, because I'm just paying horrendous amounts for fossil fuel. And that was the point where I said, okay, one, I have to move out, and number two, let's give this technology to other people also in an affordable way, and try to make it as affordable as possible. We're not charging an arm and a leg for the heat pumps for the social housing, because it should be available for everybody, and not just for, I don't know, investment bankers.
Of course. Thank you so much for the discussion. We are actually a bit over time, but I would like to ask you one more thing from off the top of your head, let's call it. What would you say would be the crucial 3 actions that need to be taken to achieve this ambition that we want in the next 5 years? Let's put 3 crucial actions for the next 5 years off the top of your head. Starting with Andreas, what would you say 3 actions for the next 5 years?
When I have to wish 3 actions, okay, the first wish would be an open funding system to bring out innovative systems in the field, because often the fundings are always very close to a technology. So my thing is, I wish that we get an let's say a framework to bring in some new solutions and to get also funding for that. Because often I get the feedback that, okay, you come up with this solution, but you are the first one, or you are not, or how does it work? You are modernizing a multiple family house. Why? So this will be the framework. This will be the first wish. The second wish would be that the heat pump lobby as itself should be more stronger. That the heat pumps are working very well in new build, but now heat pumps are working very well in modernization too, and fulfilling all the requirements for a building, and according to high comfort, ecological heating on low costs, it's possible. And this is what the whole entire lobby on the heat pumps must bring out very stronger than before. And the third thing will be, yeah, just do it. I'm a person who is hands-on, and yeah, I would love it to bring some solutions into the market and make the people happy with our solutions.
Perfect. Just do it. That's something that everyone can remember. What about you, Martin? What would you say would be the 3 wishes?
I think my first wish would be that everybody takes responsibility, and we do what we can do. So the politicians do what they do, manufacturers do what they can do, and the end users can do what they can do. And I think the discussions before this event, which we can't talk about, there was a lot of discussion about the young generation pushing pressure on politicians to change for a more sustainable world. And if I look at the crisis, current crisis, and I have to compare it to the climate crisis, I need to say that the current crisis is probably a smaller problem. The climate crisis is far bigger problem, and it's far more difficult to change it. When I see what's possible now, how the governments, how everybody reacted in this current crisis, and the outcome, then it encourages me that this could be possible, and that's what would be my big wish, that this is actually possible in the climate crisis as well, and all the other things will fall into place then. An implementation plan considering everybody, every actor, and it can be a win-win. For social housing, if you reduce the heating bills, it's a win. It's a win for the end user. It's a win for the building owner, because the property value of the building is increased. It's a win for the government because it meets the CO2 emission targets and so on. So we need an implementation plan which shows that it's a win-win solution for everybody. I don't have no more wishes.
I think that was quite enough, and very good point. Of course, the situation we're facing now pales in comparison with the problems that climate change will rise. But hopefully we will be ready, and your work for sure is laying the building blocks in the solution towards tackling that. What about you, Sebastian? What would be the 3 wishes you would have for the next 5 years?
Okay, so it would
for heat pumps, of course. No.
Okay, for heat pumps, good. No, so it would be funding, policies, and regulations. So number 1 would be government funding, that these projects can be started and realized and help the clients. This is the most important one in my opinion, because this makes it possible, you know. The second one is policies. Nobody will change their fossil fuel system if there is no policies to upgrade your building. That is another problem, you know. and this has been taken out on the backs of the residents. So there should be a policy that the landlords have to change their system, upgrade it in any way, you know, put on solar PV or something, heat pumps. This would be very helpful if finally somebody would get into gear, you know, and move it ahead, you know, where this is this. Plus also the regulations. I think the regulations have to be changed, that we fit good systems, because there is a lot of bad systems with heat pumps also, you know. So I think they have to make like guidelines how to do this and that, you know, because fitting a heat pump is good, you know. Mostly they are good, but it's just the combination of system and heat pump which can give heat pumps a bad name, and we don't want a bad name in the industry. Nobody wants it, and I don't wish anybody a bad name. If somebody tells me the heat pump from this manufacturer is bad, then I say, okay, how did you do the system? You know what I mean? I don't question the manufacturer, I question the system actually. Mostly. Okay, that would be my 3 points. So funding, important, and policies.
So
thank you.
Thank you so much. Seems a lot of work for you, for us, for all the stakeholders involved, to make at least some of these wishes come true in the next 5 years, hopefully in the next 10 years. Again, thank you for participating in this webinar and accepting our invitation. Thank you for your work. Thank you for laying the groundwork and your contribution towards the main goal. Thank you for your ambition, perseverance, for the time and work that you spend on this project, on your products, on making them accessible, on communicating their advantages to the end users, to the building owners, on, let's say, promoting them, promoting your companies, and doing the very important part that is sometimes overlooked, of providing the heat pumps to the renovation, doing basically the mini heat pump, putting them in cabinets, so they're basically hidden, but they have such an important part to play in the world that hopefully all of us wish to live in. With that somber or happy or however you might take it thought, I thank all the participants for joining us today. Of course, we hope to see you on all of our webinars. I hope you enjoy this webinar. Send all the questions to our communications team, and we will make sure that they are passed to the speakers. Again, big thank you to the speakers and the organizing team at EHPA. Have a pleasant afternoon or lunch break, and talk to you soon. Thank you so much again.
Thank you.
Thank you.
Thank you.